To get regular updates, subscribe to our channel and click on the bell icon. Visit our channel and get more learning videos under playlist option. There you can find current affairs, daily vocabulary, banking awareness, aptitude and much more. Hello friends, this is Manohar Veera from Exambing. In this session on quantitative aptitude, we are going to see about simple interest and compound interest. This session will not only be helpful in dealing with competitive examinations, but also helpful in your real-time situations. We often come across terms like simple interest and compound interest. But many of the times, we only deal with simple interest in our real-life situations. When you have an emergency requirement for money, you will obviously look for your friends and family to get some amount. Many of the times you won't be paying any interest on that amount. But in case if you are borrowing more than 10,000 or 20,000 for a definite period of 1 or 2 years, you might be interested in giving them some of the portion as interest in the principal amount. So normally what we do is we will apply some simple interest like 1% per month or 2% per month and add it to the principal and then give them back. But when you approach any bank for any kind of loan like housing loan, car loan or even for your educational loan, the banks would be charging compound interest only. Banks would normally charge compound interest on monthly or quarterly basis. So you could also see that term deposits you are making with banks will also accrue compound interest, but that will be only based on quarterly or half-yearly compounding only. But that also some banks have limitations that only if you make deposits for more than 180 days they will give compound interest, otherwise we will accrue only simple interest from the banks. Before we see compound interest in full detail, first look at the simple interest and how it works. To understand the simple interest concept, let us look at a real-time example to understand this. We introduce two characters to understand this, Santosh and Raju. Santosh has borrowed from Raju an amount of rupees 1000 for a period of 3 years at the rate of 20%. So what is the amount Santosh has to repay to Raju after 3 years of period in simple interest of 20% per annum? So in this example, you need to closely look at three important factors. Number 1, how much amount is lent? Rupees 1000. Number 2, how much is the rate of interest? 20%. Number 3, how long the amount is borrowed? For how long period the amount is borrowed? 3 years. So the three factors only determine how much amount Santosh is going to repay to Raju. So for first year, the principal is 1000 rupees. Rate of interest is 20%. So 20% of 1000 rupees is 200. So the interest accrued for first year is 200. In simple interest, if you borrow for 1 year or 100 year, the interest amount for any year in the period is not going to differ. The all years interest amount will be unequal. For second year also, the principal will remain as 1000 rupees only, and you're going to apply the same 20% interest for the second year also. So the interest amount will be 200 rupees. For third year, the same thing will apply and the interest amount is 200. So add all these three values, 200 plus 200 plus 200. The total interest amount is 600 rupees. So Santosh has to repay to Rajiv an amount of 1600, which is inclusive of principal of 1000 rupees and interest amount of 600 rupees at the end of 3 years period. By closely looking at these 3 years term, what you can determine is what we are doing for every year, the interest amount is principal into 20%, that is 200. So 200, 200, 200. So finally what we have did is 3 into 200, 600. The total interest is calculated. So the formula for calculating simple interest for any amount, for any period, for any rate of interest would be the interest amount is equal to principal into rate of interest into time period. So if you are giving the rate of interest per annum and in percentage means you have to divide the whole value divided by 100 to arrive at the exact figure. So it will be PRT divided by 100. Now let's see the same problem by applying compound interest. Now Rajiv has decided to lend money to Santosh only in compound interest. The year is same 3 years and the amount also is same 1000 rupees and the interest rate would also same 20%. So here what we need to find is at the end of 3 years how much amount did Santosh need to pay to Rajiv if the interest rate is 20% per annum and it is compounding annually. The principal amount is 1000, interest is 20% compounding per annum and the period is 3 years. The basic concept of compound interest is the compounding period, that is in this example the compounding period is given as annually. At the end of compounding period, whatever the interest amount accrued is added back to the principal. So here for the first year the principal amount 1000 and the interest that is accrued on the first year is 20% of 1000 rupees is 200. So at the end of first year the total amount would be 1000 rupees plus 200, 1200 will be the opening balance for the second year's principal amount. For second year the same technique will apply. The opening principal is 1200 and if you add 20% of 1200, that is 240, the total amount will come to 1440. This 1440 will be taken to the third year's opening principal. Again 1440's 20% is 288. So at the end of third year the total amount would be 1440 plus 288. The total amount would be 1728. So the technique is principal plus interest amount equal to principal plus interest. So at the end of every year the same thing will follow. The the closing balance of previous year will be the opening balance of this year. So likewise you need to calculate for 1, 2, 3 years. The amount after 3 years in this example is 1728. By comparing with the simple interest and compound interest for this small amount for very limited period of 3 years, it is 1600 in simple interest and 1728 in compound interest. There is a difference of 128 rupees for this small amount. If the compounding frequency is increased like half yearly or quarterly or monthly means this variation between the simple interest and compound interest would be increasing heavily. So this is why banks will always lend you in compound interest and many of the times they will avoid you paying compound interest by giving you interest in deposits in simple interest only. So calculating compound interest is easy, right? But in real-time competitive examinations they will be giving you questions like you need to calculate compound interest for 10 years which is compounding quarterly for the rate of interest 18%, like that. That will be a little bit complex if you do like this step-by-step process. For that we need to know some shortcut formulas, not shortcut formulas, traditional formulas. But instead of memorizing the compound interest formula, what we are going to do now is we are going to arrive at the formula using the example we have seen. So in the example what we have seen is the amount of principal 1000 is lent for 3 years at the rate of 20%. So the only thing you need to know to arrive at the formula is converting the interest rate into decimal. So the interest rate is 20%, which can be written as 20 by 100 and that can be written as 0.2. So first year what we have did, 1000 into 20% of interest is equal to 1000 rupees plus 200 is equal to 1200. So in other way how we can write is 1000 into 1.2 is equal to 1200. For next year what we are going to do is this 1200 rupees into again 1.2. The amount would be 1440. So for third year, again what we are going to do is this 1440 into 1.2, that is 1 plus the decimal number of the interest rate 20%, 1.2, is equal to 1728. This is far easier than the previous method, right? We can make it even easier than this by using exponents. So what we have did is 1000 into 1.2, again into 1.2, again third time into 1.2. So 1000 into 3 times 1.2. So what we are going to do is 1000 into 1.2 power 3 is equal to the amount you require, 1728. So by replacing the numbers with variables, we can get the formula for compound interest, that is compounding annually. The amount required is equal to principal into 1 plus rate of interest, the whole power period, that is T. So here what we have did is amount is equal to principal 1000 rupees into 1.2 power 3. So 3 is years, T, 3 years, and 1.2 is the 1 plus rate of interest, 1 plus 0.2. So that is what we are writing as using variables. Okay, what if the amount is compounding more than once in a year? What we need to do? Many of the times you can see that banks or in competitive exams, the questions will come like the amount, the rate of interest is compounding in monthly basis or quarterly basis or half yearly basis. So this is nothing but half yearly basis means the compounding frequency is 2 times per annum. Quarterly basis means the compounding frequency is 4 times per annum. And monthly basis means the compounding frequency is 12 times per annum. So we need to do a little bit of adjustment to our existing formula of compounding interest. So the formula is amount is equal to principal into 1 plus rate of interest, the whole power T, that is time period. So here we have another factor like compounding frequency per annum. So take the same example. There the rate of interest is 20%. What in case the rate of interest is compounding half yearly? So the compounding frequency is 2 times per annum. So the rate of interest given is 20%, that is per annum. So here the frequency is semi-annually, that is half yearly or once in 6 months. So for an year, the frequency of compounding will happen 2 times. So what we need to do is, we need to find the rate of interest for half year. For the whole year is 20%, for the half year is 10%. How we are calculating? 20% divided by 2 is equal to 10%. So in the same formula, when representing the rate of interest, you divide it by number of times it is compounding in a year. So 2 times for half yearly, 4 times for quarterly, and 12 times for monthly. So the same number of frequencies has to be denoted in time period also, because we have divided here. So in time period, instead of T, it will come NT. So the final formula for calculating the final amount of compound interest with principal is equal to principal into 1 plus R divided by N, the whole power NT. Here P represents principal and R represents rate of interest, T represents time period, and N represents number of times it is compounding in a year. So we have seen the concept and formula derivation for simple interest and compound interest. Let us look at some example problems that is asked in competitive exams to understand how we can calculate the real time problems that is asked in examinations.